Welcome to today's presentation. This video is about probability tree diagrams, combined events. The question reads, Part A, the probability of a school winning in football, volleyball and netball are 2/5, 3/8 and 4/5 respectively. Find the probability that, then Roman 1, the school wins in all the games, and then Roman 2, the school loses in at least one game. And then finally for part B, 3 officials are chosen from a pool of 9 girls and 11 boys. No student may hold more than one docket. Find the probability that all are boys, and then for Roman 2, only one is a girl. So straight to part A, Roman 1. We have to find the probability that the school wins in all the games. Remember we had 3 games here, football, volleyball and netball. And we also have the probabilities of the school winning in the respective games. We will represent this information on a tree diagram, and the first branch should represent football, and the school either wins or loses in a football match, and the probability, so this is losing. So the probability of the school winning in a football match, we are told, is 2/5. So we have 2/5, and therefore losing is 3/5. That is 5/5 minus 2/5, because the sum of these two should be 1. So we are done with football. The next branch we will have volleyball. So for the case of volleyball, the school either wins or loses too. Here wins or loses. So the probability of the school winning in a volleyball match is 3/8. Losing is 5/8. Again, we take 8/8 minus 3/8, so that we get 5/8. And this will repeat down here. So we have 3/8, 5/8. And with that, we are done with volleyball. Finally, for netball, we form another branch. So the school either wins or loses in a volleyball match. So the order has to be maintained all through. So the probability of the school winning in a netball match is 4/5. So we have 4/5. Losing is 1/5. And this will repeat throughout downwards. So we have 4/5, 1/5, 4/5, 1/5, 4/5, and 1/5. And then from this, we'll be able to get a list of all possible outcomes. So for this path, we'll have the school winning in football, winning in volleyball, winning in, this one was netball, sorry. So for the last part, winning in netball. And then for this path here, we have a win, and a loss. Then we have a win, a loss, and a win. For this path here, we have a win, a loss, and a loss. Then next we have a loss, a win, and a win. Loss, win, and a win. Then a loss, a win, and a loss. Here we have a loss. then a loss, and a win. And finally, we have loss, a loss, and a loss in all the 3 games. So with this, we can therefore answer the questions that follow. So we are told, find the probability that the school wins in all the games. So that is for this case, where we have all the games being won. So we have the probability of winning in all the 3 games being, so following this path, we'll multiply 2/5 times 3/8 times 4/5, 2/5 times 3/8 times 4/5, and this should be 3/25. That is for Roman 1. Then for Roman 2, we need to find the probability that the school loses in at least 1 game. So at least 1 game, that means 1 or more games. So we have here the school losing in all the games, here 2 games, 2 games, only 1 game, 2 games here, 1 game, 1 game. And that means we are supposed to get the probabilities of all these and add them up to get the probability of the school losing in at least 1 game. But the shortest way of doing this is by considering the probability of winning in all the games, and then you subtract from 1. So the probability of losing at least 1 game, so at least 1 loss, this should be equivalent to 1 minus the probability of winning in all the games. Remember, the probability of losing in at least 1 game appears in all these except for this part. So we just take 1 minus this, and that will represent the probability of losing in at least 1 game. The probability of winning in all the games we'd already worked out here. We have 3/25, so we have 1 minus 3/25, and this should be 22/25. Sorry. Lastly, for part B, 3 officials are chosen from a pool of 9 girls and 11 boys. No student may hold more than 1 docket. That simply means when a student is chosen without replacement. So we have to find the probability that all are boys. Again, here we are going to draw a tree diagram, and for this case, the first branch should represent the first official, and the official can either be a boy or a girl. And we are told that there are 11 boys out of 20 students and 9 girls out of 20 students. So if in the first selection a boy was chosen, in the second the number of boys should reduce by 1. So if in the first selection a boy had been chosen, then the number of boys should reduce by 1 when we move to the second selection. So for the second selection, the number of boys should be 10 out of 19 students. Remember, the official had been chosen and set aside, is not replaced. And then the number of girls here still remains the same, that is 9 out of 19. Remember, the sum here should be 1 or 19/19. And if in the first selection a girl had been chosen, then the number of girls should reduce by 1 in the second selection. So we have 8/19, and the number of boys will remain 11. because a boy was not chosen in the first case. So that should represent the second selection. And then lastly, for the third official, which will either be a boy or a girl, if in the second selection a boy had been chosen, then in the third selection the number of boys will realize shall have reduced by 1 again, so that we have here 9 over 18, and the number of girls will remain as 9 again out of 18. And if a girl had been chosen, then the number of girls here should be 8 out of 18, and here 10 over 18. The same applies to this part. If a boy had been chosen, then the number of boys will be 10 out of 18, and here number of girls 8 over 18. And lastly here, if a girl had been chosen in the second selection, then we have the number of girls reducing to 7 out of 18, and then the boys are still 11 out of 18. So the list of possible outcomes are a boy in the first selection, a boy in the second, and a boy in the third. Here a boy, and a girl following this path. And then you have a boy, a girl, and a boy. Boy, girl, boy. Here we have boy, girl, girl. Here, girl, boy, and a boy. And then girl, boy, and a girl. Here we have a girl, and a boy. And lastly, a girl, and a girl. So, in this question, we are asked to find the probability that all are boys, and that is this first case here. So we'll get the probability that all are boys being, so following this path, we'll have 11 over 20 times 10 over 19 times 9 over 18. And when this is worked out from my calculator, I'm able to get 11 over 76. Lastly, for Roman 2, we have to find the probability that only one is a girl. So that we'll be able to obtain from the list of possibilities. Here we have at this point only one girl. Here we have only one girl, and here we have only one girl. So we'll have the probability of this or this or this, and that we'll obtain by following the respective paths. So for this part here, we'll have 11 over 20 times, so we follow 11 over 20 times 10 over 19 times 9 over 18. So times 10 over 19 times 9 over 18. And then we'll add that to the probability of this, of which we follow this path, 11 over 20 times 9 over 19 times 10 over 18. And we'll add it to this case here, 9 over 20 times 11 over 19 times 10 over 18. And when these are worked out, for this case here, we should get 11 over 76 plus here also 11 over 76 plus here 11 over 76, and this should give us 33 all over 76. And With that, we mark the end of the solution to this problem. Thank you for watching. Hope to see you in the next video. Bye.